Alright guys, I'm going to try this out and see how this works. See if it'll help you follow along and get it pretty well. So what we have is the wild type and vestigials from all generations so far. We will count the 6 generations when we have them. But what we need to do is determine if evolution happens. And the way that happens is, since Hardy Weinberg says that everything kind of stays the same, right? No evolution happens. If that were the case, when we start out with the original vestigial and wild type flies, at the end we would end up with the same frequency. Regardless of the number of flies that we have, they would of course keep reproducing and growing, but if there's no evolution, then the frequencies will stay the same. However, if evolution does happen, the allele frequencies will change. Now, what we're going to do is the first one we're going to look at with no predator. So in Excel, we've already got it in. It's a nice little template laid out for you. So the first thing we do is we go over to the totals column and we can just hit equals and just do, do that. Then we sum it. You just start typing the function that you need, double click it, and right now we just want to know which one's which. That one, comma, and that one, and enter. There's our total. Now remember, in order to copy the functions from an Excel column, you can put it on the bottom right hand corner to where you get this black little plus sign, left click it and drag it down. Alright, that fills the functions. And if you double click on it, you can actually see which boxes it highlights. So if you were to do that, but you wanted to do the same function, but if the values that you're wanting to use in the function aren't in the same row, then you'll have to change that. But as long as it's still going straight across, then it'll copy it just fine. Now this gives us our totals. So we go over here to Q, and if you remember, think back, Q is going to represent our recessive genes, and P our dominant. So how do we do this? Well, remember in the beginning we did 30/70, which a simple little 0.3 for the, or I'm sorry, 7 for the Q and 0.3 for the wild type. That just tells us 30% are wild type and 70% are vestigial. Now these are, we know these are this because they are homozygous. We know this because when we ordered them, that's the way they were. Just ignore sex, that doesn't matter. Q squared, alright, so I messed that up. Let's clear it. So put it in the wrong one, right? Okay, so here we have Q squared is the vestigial divided by our total number equals that. This one, Q, is actually going to be equals and square root of this, and that is what we come up with. Okay, now we can pull this over. So remember, when you slide the cell, it's the white box. All right, now if we do this, remember it will fill all cells. And we have a div/0 at the bottom. Why? Because it's not there. Okay. Since we have it like this already, remember we don't like all those decimal places. So 2 at the most will be fine for this. For P, so if it's not a Q, then it has to be a P, right? So we just simply do a 1 minus Q equals. And again, we can just fill it down. What this shows us is that we have 83% of our flies in the no predator cage are now wild types. Okay. All right. So if you guys are all kind of caught up and kind of understand what we're doing now, question number 1 has asked if evolution has occurred. Remember, what we want to know is our observed values, are they different than what we expect? Since we started out with an initial P frequency of 0.3 and initial Q of 0.7, that's what we should end with, right? Remember, it doesn't matter about the number of flies. So Q squared is, remember we just do that, click on Q squared and up and to the second. So we need to delete that. So the number of vestigial flies, this is asking for the proportion. So what we have to do is just simply equals our total number of flies at the end. And remember, I'm just using 5 generation because that's what I have data on. We will actually use 6. So the total number of flies. This is just saying that, okay, Q squared is the proportion of flies that are actually Q, or wild type, or vestigial. So if no evolution occurs, this is what it should end up being, right? Okay, so we do that, then times that, and that comes to 67. So this says that if no evolution occurred, then we would have 67.6. So we can't have 0.6, so we would have 60. We should have 68 of them that are vestigial flies. So now we know how many vestigial flies we should have. How do we find out the number of wild types? Alright, we're going to equals, and we're going to take our total number of flies at the time and subtract those. And there we go. Okay. Q is there, and just paste values so it doesn't paste any formulas with it. Copy and paste P, and there's that. Now should be able to pull this over, makes the function. Now we can pull these over and it gives us our percentages, but there's a little problem there, and let's see if we can figure out what it is. Okay, so when we slid it over, it actually slid our total column over, so we have to slide that back over. And again. So that is what we have. Now, if you notice, these numbers are already up here. We just kind of copied and pasted and redid it so you can see how it goes. The p-value. this is going to be a little different. We're not going to do an ANOVA, we're going to do a chi-square test. So go to here, chi-square test, double click. Actual range is what we had, and comma, expected range is what we expected to happen, and hit enter. So the p-value shows that it is well below our 0.05 value, which means that evolution did happen. Okay, now for question 2, it wants to know if what populace predicted matches what we have. Now, if you remember back, the populace model just kind of predicted it based on the fitness level of one of the flies changing. So that's all we manipulated. We changed from the vestigial going from a fitness level of 0.4 to 0.8 to 1, and then we started changing the P fitness. So for the no predator cage, you were asked in the beginning of the course to kind of see which one it fit, right? Which one does it best match? So if you go up and look at your observed values, we have a 0.83 for the P. So go to your original hypothesis in populace and look at it and see which one matches. Maybe model 1, maybe model 5, whichever one it is. Now I'm going to use this one for example in the beginning. I'm just going to say that I said model 3, my p-value was 0.58, q was 0.42, and these are the same equations. Alright, so q squared is just q squared, and the number of vestigials is just the total number times our q squared, and then our total minus our vestigials gives us the number of wild type. So we go back up here and we can simply do this because it is the same thing. Just paste the number in. Alright, now I want to slightly adjust all the values because there's no need to have 50 billion numbers. For the actual numbers, we can get rid of all of them because you can't have a partial fly. So that's what we have. And again, we just need the p-value to see how these compare to each other. So now we do equals chi-square test, actual, and expected. And we have still statistically different. What does that mean? That means that what we have didn't match what I thought it would be. That populace model says it would be. So they're not all at fitness level 1. Okay, so what do we do now? Well, we need to change it a little bit. So I'm going to change it to, I'm going to raise it to 0.68 because that's my number 4. So that comes to 0.32, or is that right? I can't count. 32, and it adjusts everything. Now, okay, we're starting to get a little closer to 1. So let's try bumping up to 0.75. 0.25, and now we're over 1. Okay, so what does this mean? If it's over 0.05, it means that they are not statistically different, which means that our observed does match this model. So do not just go in and put in numbers, just actually make it fit one of your model values.